Okay, sports and outdoors section, sports and fitness, hunting and fishing, shooting, on Amazon. Goes to air guns and accessories. And because people are tired of Amazon censoring stuff that they're selling, it has 22 caliber, 25 caliber, and 27 caliber. 3 to 12 cents a pop. Blanks. They're based on nitroglycerin and a whole sorts of things. Probably against their rules. For driving nails. These are nail gun blanks. They're called powder actuated thingamabig. Anyway, at the far end of it, under a specific way of measuring things, a 350 grain projectile is fired at 1,300 feet per second. That's almost 400 meters per second. That's in that range. And this explosive propellant containing nitroglycerin in these calibers. Also, Olin made tool loads that were 32 and 38 caliber. And they can cost literally as little as 3 cents a pop instead of 5, like you would a normal 22 caliber bullet cartridge. You know, Blinkster stuff. All the way up to 12 cents a pop, which makes them much more expensive. But again, you can get 32, 38, 25 caliber ACP sized, or are they? A lot of these are neck down cartridges. Now, why is this used? Well, let's go into actual work. Requirements. OSHA rule such and such. Power level for cased and caseless loads be identified by specific coloring and numbering system. Now, I'm going to read the feet per second, but remember, this is a blank. There's nothing coming out of it. 300 feet per second, gray, number 1. Number 2, brown. We're already in brown, almost 400. Number 3 is green, almost 500. Number 4 is yellow, 575. 675 for red, number 5, and purple is 750 feet per 55 feet per second. That's the brass casing or caseless muzzle load velocity, and these are considered probably low speed. Now we get into the other range. Nickel and or silver casing. What that means is it's a different color coding. And now we have gray again, but this is number 7 power load. That's 845 feet per second. We get 930 with brown. Number 9 green level is 1,000 feet per second. And yellow is 1,100 feet per second, number 10. Then we get red 11, number 11, at 1,200 feet per second. And then purple nurple, the purple nickel canister or purple silver canister. Number 12 value, 1,300 feet per second. That sounds impressive. Well, look for the fine print. This took me 60 pages to dig up. High velocity is over 300 feet per second. None of these are low. That should be a first clue. That's for piston type, low velocity, under 300 feet per second. For low velocity. High velocity is over 300 feet per second. Well, how is this measured? At 6.5 feet from the muzzle of a test firing device, using this to propel a 350 grain, 23 gram, 3/8 inch, or 37 to 38 caliber, or 9.5 millimeter diameter nominal velocity ballistic slug sample. Wait a minute, we're taking a 22 and necking it up. Instead of it making it go fast, it goes slower because it fills up a piston to drive something. Most of these are piston types, which means they take a tiny explosion, spread it out over a large area. The exact opposite of what you do with a 223 neck down cartridge or whatever, to take a big container of propellant and squeeze it through a tiny hole to get speed out of it. This lowers the speed so you can pack more punch with weight. And no, we're not talking about this about muzzle velocity, because the muzzle velocity is actually these numbers, these big numbers. But it spreads it out, well, it's almost 40 caliber, and it's a 22 diameter for the nozzle. That's twice as wide and that's 1/4 the speed with the pressure spreading out at minimum. I'm rounding it off horribly, but if something says it can go 1,300 feet per second for purple nurple, divide it by 4, that's 7. Divide it by 4 again, it's 300. This is just barely in the high-speed category, depending on what you do with the compression and expansion. That's it. This is like the oil-filled drum you hand crank to lift up. It uses a little piston on this end to push on a really big piston over here. It moves really slowly, but it can lift tons of weight. The idea is to have a lot of force pushing a fairly heavy piston hammer violently into a nail and be able to drive it through steel and into concrete and wood, sometimes all three. The OSHA rules require all sorts of things. It has to design the tool so it cannot fire during loading or preparation to fire, so it's a lot like a real gun. Or if the tool should be dropped while loaded, drop test. Dependent upon no less than two separate and distinct operations of the operator. One of them has to be that it has to be placed by the operator, and another one has to be, it can't be, the last stage is that it's simply put upright. The last stage has to be it being impacted or trigger pull. It has to be held against the work surface with no less than 5 pounds extra force over its own weight, which means you're pushing down on it with more than 5 pounds of force. That's the equivalent to a 4 or 3 pound trigger pressure. Designed that all breaching parts will be reasonably visible to allow a check for any foreign matter that may be present, to prevent a bore obstruction, and make it to where you can make sure there's no ammunition in it. So can this be used as, essentially at this point with the piston one, a captive bolt stun gun, like out of No Country for Old Men? Technically, yes. In fact, it has a lot in common with it. But, well, here's the big one. The barrel on these things is able to take this because it directs it to an internal piston in most cases. The other ones directly act on a plunger that's built into whatever you're firing. Now, I'm going to include the diameters and dimensions for them below that people measured by getting out calipers. But 27 caliber cases will have a rim diameter 33 caliber, rim thickness of a small thickness. The body diameter is almost exactly 27 caliber. And the overall length is 1/2 inch. Height to bottom of the crimp at the top is actually 2 3/4 inches. Or no, excuse me. From the bottom of start, and of course it includes almost a 27, a 2-to-1 ratio. Basically the crimp at the top is at a 45-degree angle. So it takes up 1/3 of an inch on top. So what's useful about that? Well, that was the 27 caliber. The 25 caliber, 25 ACP sized, diameter at the rim is 30 again, and the body diameter is 24.4 to 24.5, so it's a 25 caliber. It's actually smaller than 25 caliber, so it would be loose in a 25 caliber gun, but it would work as a blank if it was rim fire. 25 ACP is center fire normally. Overall length is almost 0.4 inches. Yeah. Height of the crimp is again a ratio with a 45-degree angle at top. Now wait a minute. Oh yeah, and the overall length for the 27 caliber was 0.411 length. Then we get the nickel-loaded 22 long rifle shot shell cases. These are made like little tiny 22 shotgun rounds, snake shot. SAMI dimensions for the long rifle cartridge are yada 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 yada, and it matches very closely. So what happened? Okay, real simple. If you take a 22 caliber blank and stick it in the ass end of a howitzer bullet that looks like a gigantic 223, let's say you had something like that, an enormous bullet-shaped thing, you could use that as the primer for the actual charge inside. So basically what's going on here is by spreading out the force in a larger area, it lowers the speed and allows you to just push things. And again, solid and liquid material, when they turn into a gas or a vapor, expand 1,000 to 1 approximately. There's a really cool video I found, and I was going to do some single frames from it, from a 209 primer out of a shotgun that's almost the same diameter as a 22, but it's about really tiny. Creates a bubble about that big around in water. It just does. it expands a very tiny amount of explosive in it, but it makes a pretty big bang, but only if it's enclosed. But the water doesn't really jump up and down much. Now, what would be useful about this? Okay, just the video here. A lot of people were looking up, can you take one of these things that's shaped like a gun and actually use it to fire a bullet? No, you can dismantle it to the point that you could fire a 22 long rifle bullet out of it. Could you use these as a cheap repulsor round to drive an actual bullet? This has actually been done, but the bullets become unstable because unless you're going to make a full-on 223 5.56 wild cartridge style 22 caliber bullet that's really long and skinny and have it go through rifling, you have to have rifling or it's not going to do any good. The thing is going to start tumbling pretty quickly because the force applied to it is too sudden. It needs to accelerate the bullet while rotating it on its axis. It's just the basic thing people found out a long time ago. The reason a rifle bullet, whether it's a 223 or even a 17 caliber really skinny miniaturized version of it, is shaped that way is because that is the shape that works. And unless you use that, you're not getting anything out of it. And suddenly you're buying something that's almost as expensive as just buying a proper round in the first place. Then you can do reloading. That's why this is something I haven't really covered on the channel, but what these are good for. You can use these as, and this is available, you don't do this, but you can do this. One of the rounds, you'd have to take them apart to find out how much grain capacity they have. But one of these rounds can be used as a DIY field expedient, you use at your own risk, on the end of a stick and a hunk of cable, as a proof round for a gun to make sure that it, use it as a cheap proof round for a barrel you're testing. You don't care if you blow it up. The idea here is that you don't put anything in there to bore obstruct it, you just set it off. These things are powerful enough because of what they contain, not a propulsive round. These are explosives in some cases, depending on which one you get. It will act as a pressure builder one, or it'll act as a shock one to see if you can find breaks or cracks or bad designs. Other than that, I'm going to say this. Using a 22 caliber blank or any of these other blanks that are used for driving nails into cement to drive a projectile is a bad idea. There are some products that are made to do it, but they take up a lot of air space. A good example is taking the knob off the ass end of a hollowed out aluminum arrow, building it up, putting a metal tube up in the middle of it, and using these to fire an arrow. It fills up a space that can be like 3 feet long and about a centimeter across, so you have exactly the amount of space needed to take up all of that expanding gases. And even they say your upper limit, it's like a number, I think it's a number 8 is the maximum you're allowed to fire, because anything above that will just break the damn gun. And this is an arrow launching gun somebody did this with. The only practical application anybody's done is taking the 27 caliber nail gun blanks design and using them to drive the actual HMR 17, a 17 caliber pellet gun sized version of that rifle bullet. That, if you want to do this, just buy that. And yes, they also made one that's 22 caliber version of it too, doing the same sort of methodology. They're really tiny versions of military grade 223 and 5.56 bullets, cartridges. That's all it is. That's all you'll accomplish. Again, these numbers look impressive because they're taken out of context. This is a pressure level coming out of something less than a 1/4 inch across being spread out on purpose 4 times over and over a piston distance this far to drive a nail into concrete. They worked this out so that they wouldn't have to overbuild the barrel. These are not bull barrels and they will not work better than a real gun. But I'm answering this question because someone asked me this in person on the street because they saw my channel. So whoever you are, he said, do a video on that. I've done it. And yes, people have done this, and it's an interesting experiment, but I'm also include videos of people showing you why you don't do it. It's because it just doesn't work. And sometimes it just jams up the barrel. Thanks for watching. Have a good day. Good luck.